Assalamualaikum everyone, how are you all? I hope you all are fine and healthy. And as these sessions are started again, a new session of YouTube videos would be started again. It would be very helpful for you for your board exam preparation and especially for the federal board exam preparation. The topic we are going to understand today and we have the explanation of is oxidation reduction. This is basically the start and the very first concept of the chapter. Oxidation and reduction are the type of chemical reactions, and most of the chemical reactions under chemistry basically are oxidation and reduction reactions. And especially in our daily life, the most of the chemical reaction are oxidation and reduction reaction. The best example from the daily life of oxidation reduction, from the daily life, for example, photosynthesis, in which the plants basically use carbon dioxide and add hydrogen from water into this carbon dioxide to form a biomolecule. Glucose is basically a reduction reaction and also involves oxidation in this chemical reaction as well. And as a whole, we call these type of chemical reaction as redox reaction. Redox means refers to reduction and oxidation reaction. And similarly, in our daily life, for example, the respiration and combustion are the basic processes. Respiration, in which the food from the plants is broken down in the presence of oxygen into carbon dioxide and water again. So these two chemical reactions are basically the best example from the daily life in which the reduction and oxidation reactions are involved. So reduction and oxidation as a whole can be defined in four terms. The first term is in the terms of oxygen, then it can be defined in the terms of hydrogen, then it can be defined as the term of loss of electron and gain of electron. Similarly, it can be defined as in the term of the increase or decrease in the oxidation state. We will go on through all these four terms one by one, and whenever, if for example an examiner is asking you about oxidation and reduction, you must give all four definitions of oxidation and reduction. Oxidation basically refers to the addition of oxygen when it comes under the terminology of oxygen, and reduction refers to the removal of oxygen. Similarly, when in terms of hydrogen, oxidation refers to the removal of hydrogen, whereas the reduction refers to the addition of hydrogen. Let's take an example of both of them. For example, if I say calcium copper oxide reacts with zinc and it forms copper and zinc oxide or ZnO, we can see the oxygen was present with the copper and forming a compound called copper oxide, and zinc was all alone, or it was a free element, you can say here. It was a free element. A free element is the element in which no other element is combined with that particular element. So basically in this reaction, the oxygen from the copper was being removed. So the removal of oxygen refers to reduction. It means reduction took place here. Whereas in zinc, the oxygen was added if you look at the other side of the chemical equation. So it means oxidation occurs with zinc in which oxygen was added. So we can say that copper undergoes oxidation and copper undergoes reduction and zinc undergoes oxidation. Similarly, in a simple combustion reaction, for example, the methane gas, the natural gas, which basically came as like the natural gas in our stoves from which we are basically cooking our food, when it reacts with oxygen, what happens? That methane loses its hydrogen, and this hydrogen combines with oxygen to form water, which basically is given off as steam, and carbon combines with oxygen to form carbon dioxide, and as a result a large amount of heat is also evolved, and this heat is used in the stoves to cook the food. Now you can see the carbon basically added up the oxygen and hydrogen actually was removed from the methane. So reduction basically took place here, and carbon was basically removal of hydrogen took place from here, and ultimately the oxidation happens here in the process of combustion. Similarly, for a chemical reaction in which nitrogen reacts with hydrogen to form ammonia, which can be helpful in several ways, especially in the production of the urea fertilizers. This ammonia was produced by the addition of hydrogen into your nitrogen. So, as addition of hydrogen took place here, so this process would be known as reduction, or we can say the nitrogen was reduced in this process. Done? Now coming to the most important part of the lecture, oxidation and reduction can also be explained in terms of loss of electron and gain of electron, in which oxidation refers to the loss of electrons and reduction refers to the gain of electrons. For example, if we say that the sodium metal basically loses its one and only electron from its valence shell and forms a sodium cation, it would be known as the oxidation. We would say that sodium undergoes oxidation. Similarly, if chlorine non-metal basically undergoes the addition of electron, the electron is being added into the chlorine and forms the chlorine anion. So we would say that a gain of electron has been taken place and it is known as the reduction reaction. So in general you can see that all the metals have the property and they are electropositive in nature. So basically we can say that all metals basically undergo oxidation, whereas all the non-metals undergoes reduction because of their electronegative property. Loss of electron takes place from the metals and gain of electron takes place in the non-metals. So most of the metals basically undergo oxidation in their free form, whereas the non-metals in their free form can undergo reduction. Now the terminology, the last point, the oxidation state. Before understanding the last definition of your oxidation reduction, we must know what is an oxidation state. Oxidation state basically refers to the charge which an element can gain or can basically decrease, can have after losing or gaining an electron. Done? So basically, what do we do here? You can see in the example which has been discussed here that sodium lost its electron and gets an oxidation state of +1, whereas chlorine gain an electron and get an oxidation state of -1. So these charges upon after losing and gaining of electron are known as the oxidation state or oxidation number. Can be called as charge number or valency of a particular element, compound or a molecular ion. Done? So now talking about in terms of oxidation state, we say that oxidation takes place when there is an increase in oxidation state or oxidation number, whereas reduction takes place when there is a decrease in oxidation state or oxidation number. And we have talked about the examples of sodium and chlorine. For example, when sodium basically give away its one electron, it forms sodium plus ion, and this is an increase in oxidation state. Hence it is an oxidation. Whereas for example chlorine, when takes up one electron, it basically forms a chlorine -1 charge, and it is a decrease in oxidation state. Hence this is called reduction. Similarly, for a particular chemical equation, for example, if we say that Fe plus 3 after gaining one electron gives Fe plus 2. Hence you can see in both of the part of the chemical equation or both of the part of the equation, it is not a chemical equation, it is basically oxidation reaction. the charges are still in the same positive charge, but the reduction of the charges takes place because there is a decrease in the charges from plus 3 to plus 2. So we can say that in this chemical equation basically Fe got reduced or reduction takes place. Done? This must be understood. Similarly, for a chemical equation, for example, a negative charge bearing chlorine, when it basically loses its charged electron, it can form a chlorine zero state. Hence, the negative charge is lower in value than zero. We can say the increase in oxidation state has been observed here. Hence, it is oxidation. So, from these examples, we can clearly see that the oxidation and reduction. In previous example, we were talking about the loss of electron and gain of electron. We were saying in general, all the metals undergoes basically oxidation because they have the tendency of losing the electron because of their electropositive character, whereas all the non-metals basically undergo reduction. Why? Because they have an electronegative character, and due to which they are capable of gaining electrons. But still we can see that oxidation state literally determines that even if it is a metal and having a cation oxidation state, it can be reduced by lowering of the oxidation state. Similarly, if there is an electron, if there is a non-metal which is already in reduced form, can be oxidized by the loss of electron. So this is this is basically a way to identify a better way to identify oxidation and reduction state. Here, this is a very important point that student must understand that in the federal board examination or in any other examination, the way of identifying oxidation and reduction reaction is because of their increase in reduction and increase in oxidation state, and this can be done by looking at there is a loss of electron or there is a gain of electron. If there will be the loss of electron and the increase in oxidation state takes place, it means it is a oxidation, and if there would be a gain of electron and you can observe a decrease in oxidation state, it would be called as reduction. Done? So this must be kept in your mind that not all the chemical reaction contain oxygen or hydrogen for the identification of redox reaction, but all the compounds or all the elements always contain electrons. So this is the one of the most reliable method to identify in a chemical reaction where the oxidation is taking place and in what ways the reduction is taking place, and this must be kept in your mind for the further acknowledgement or further explanation of the later topics of the chapter. Is it clear? So this is all for today. So let's have another session, and that another session would have the role of oxidation state and how we can calculate the oxidation state of different elements, compounds, molecular ions and complex ions. Done? Okay, Allah Hafiz, have a nice day.